I've been playing the cello since I was 9 years old, and I've been in the National Symphony since 1978. There are a number of connections between math and music. There's 5 lines on a staff of music. We have lines and spaces. It's kind of like a graph, a math graph. And you have the vertical component, you have a horizontal component, just like on a math graph. And the vertical component shows pitches, higher or lower. And the horizontal part, that's your speed, your rhythm, your tempo. And then composers use a tiny vertical line at the end of a bar of music. So those little vertical lines tell you how big your group is. And we call those bars or measures. So it's all, again, a lot like a graph. Once you learn how to read it, you can tell what all this information is. I happen to be good at math and science, and I happen to be pretty good at music too, but it never occurred to me until I was much older, until I started trying to teach kids how to play the cello or teach them music. And then I started realizing, aha, they didn't learn fractions, and so that's why they can't read music. This is a metronome, and what you do is you turn this on and you set it to tick a certain number of times per minute. I have it set on 80 right there, so it's beating 80 times per minute. And this is how we kind of learn fractions in music. So while I play the note, you hear it ticking 4 times. 1, 2, 3, 4. Next whole note. 1, 2, 3, 4. Now we're going to play half notes, so we'll only hear it tick twice. 1, 2, 1, 2, 1, 2. Now quarter notes, we'll hear each click is 1 note. 1, 2, 3, 4. So now you see I'm playing 4 times as fast as I was for the whole notes. And of course we can have 8th notes where each click, I have to play 2 notes for each click. We have 16th notes. I can even play 32nd notes. And of course, in music, we have combinations of those things. You don't have all the same. You could have half notes, 1, 2, 1, 2, and then it's a bunch of quarter notes, 1, 2, 3, 4, and then maybe a couple of 8th notes. And that's what makes music, is these combinations. But you have to be counting and constantly doing these fractions while you're playing music. As a performer, you find that you have to be counting constantly. In order to play music, you have to have a very highly developed sense of rhythm. And in music, we use a lot of patterns as well. Well, the simplest patterns that we have in music are scales. There are 24 different scales that you have to learn, and you have to learn the patterns for each of those so that when you're playing music, it becomes instinctive. Composers use patterns all the time. If I were to play just about any piece of music for you, I could probably show you some patterns in the music. String instruments use math in a lot of funny ways. I mean, if you go all the way back to the time of Pythagoras, he did some experiments with string lengths, and he made some discoveries. Taking a vibrating string, if you divide the string in half, you raise the pitch of the string by an octave. There's some logic to what we're doing. It's these mathematical principles. It's not, you know, some mysterious thing. When people talk about someone having a good sense of rhythm, like a jazz musician, usually what it means is that that person internally has like a little clock going that's very regular or very steady. When you stop counting to yourself, your sense of rhythm goes right out the window. Musicians know, sort of intuitively, which of those chords sound good together. So when you're hearing them improvising, it's not nearly as random as people think. They aren't just making it up as they go along. Yeah, there's an element of that, but it's all based on some very fundamental mathematical principles of counting and harmonization and recurring patterns.